And welcome back to Educator.com's Advanced PHP with MySQL course. In today's lesson, we're going to be talking about a SQL concept known as joins, which is going to allow us to query data from multiple tables in the same time. Before we get into actually working with joins in particular, we're going to talk about a couple topics. The first thing that we're going to do is we're going to introduce a new SQL type that we're going to for columns in our database called date time, which is going to allow us to basically store a timestamp, a date time value. And then we're going to talk about how currently in our web application, when a user creates an order or submits an order in the store, it actually emails the store administrator the information about the order. Well, we're going to be changing that system in our next version of the web application to where it's actually just going to store the order information in the database as opposed to sending an email. So we're going to discuss in today's lesson about how we might model orders within our database. It's going to involve an orders table, it's going to involve a customers table, and then that's going to bring us to our concept of joins, which is basically where we're going to be learning how to write queries that get information from multiple tables. And we'll see, and that's going to relate to how we pull information about orders from our database. As far as joins go, we're going to talk about something called join conditions, which is basically like a where condition that's going to allow us to specify what data we want to pull from multiple tables. We're going to talk about two other related concepts, one known as an implicit joins, something known as aliases, which is going to make your SQL statements cleaner looking. And then also we're going to go over required homework, which is going to have you basically set up the orders, the tables in your web store database, so that you'll be able to run our next version of the web application, which is going to store orders within the MySQL database. So the first thing we're going to talk about again is a new data type called date time. It's a MySQL data type, and it allows you to basically store a timestamp. So for example, if we wanted to create a table called orders, you might have a number of different columns, and this is an abbreviated create table statement. Let's say we have an order ID that's an unsigned int, and I left out maybe it's primary key that's an auto increment, but that's just one column. And then let's say we have a column called date time ordered, which is going to be the date and time that a order was processed. Well, we can store that as a data type called date time, and basically what that does is that stores a date and time stamp for that column. So for example, in MySQL, it stores them in this format here, where you have the 4-digit year, 2-digit month, 2-digit day, and then you have 2 digits for hours, minutes, and seconds. And basically what you can do is we're going to be creating a timestamp when an order is processed. Currently, we have been using the date function within our email order function to basically generate a timestamp on our order. For example, when we place an order on a website in our current web store, it shows you a date and says your order was placed at so-and-so time. Well, we're still going to use that date function, but we're going to be storing it in the database. We're going to have to specify how we create the date string, because for MySQL it needs to be in this format here. And basically, we're going to be using date with, as we know with the date function, you provide it some sort of formatting string that's going to allow you to describe how you want the date stored. So when we add an order to our database from PHP, which we're going to see in our next web application, we're going to be using the date function to generate this date string that we're going to store in the database. One thing to note is that you could also just store dates as regular strings in the database. For example, this right here is just a regular string. In essence, you could have and just have that be a string, and then store that in your database and be able to extract information from it. Well, there's a distinct advantage to using the datetime data type as opposed to maybe using a varchar, or you could use even a char for this type of data, because it's going to be of a known length. In that, because MySQL will know that it's a date time, that the column data represents a date time and is not just a string, you can perform operations on it. For example, you'll be able to do things like maybe you only want to get, let's say you want to query your database and say, give me all the orders that happened in the last month. Well, MySQL will be able to use the fact that a particular column is a date time column to be able to basically develop a query with results based on criteria you specify. If you had just specified it as a varchar, for example, MySQL won't be able to do that. So how could we model orders in our database? Basically, orders contain a bunch of different information. We know that when we create an order, it has items in the order, it has the quantity of those items, and then also the order involves a customer submitting their name and shipping information. We also just found out that we're going to be, and as we've had in our email, we have a timestamp for a particular order. So there's a bunch of different information. And we're going to see that as like in our departments, it doesn't necessarily fit all into one table in our database. So if we look at a couple of ways to modeling it, let's say we had a table called orders in our database. Maybe we store an order ID. We would store the date and time of the order. And then we could store information like the customer that ordered it. We'd store their name. And let's just to simplify, rather than putting all the different columns we have like city, state, and address, let's just say address. And then maybe we would have item 1. And then you could list the item number. And then item 2, or item 1 quantity, item 2, and so on. And so this would sort of be the structure of our, this could be the structure of our orders table. Now hopefully what you remember from our lesson where we talked about linking tables in departments, that this is not a normalized data, and that if we have a column for every item that we want to add to a particular order, then it limits the number of items we can have in a particular order to the number of columns in the table, so we'd constantly have to be updating the size of our orders table to add columns for new items. So for example, maybe be order ID 1, I'm just going to put 2011, blank, just some string. Maybe item 1 is 1001, the quantity purchased was 2, maybe item 2 was 1003, and so forth, dot, dot, dot. Well, we know that that's a problem, and we can normalize that. So one thing that we're going to do with our order database is we could change the structure a little bit. So now we'd have two tables. We'd have one called orders, which would contain all of the information except for the items. And then what we can do is actually we create another table called orders items, which would be a linking table, which we learned about in departments, where we would link multiple items to a particular department. And here we could have two foreign keys that make up a primary key of the table. We could have an order ID and an item ID. So for example, order 1, we could have an entry that says item 1001 was part of order 1. For each additional item that's in order 1, you could add information. Additionally, because we have a quantity associated with an item in order, we're going to have a quantity column. So we could say there were two items 1001, two 1001 items in order number 1. There's one 1002 item. And so basically now we've normalized our database, and we can add as many items to a particular order as we want without having to change the structure of our database. Additionally, one other thing I'll mention while we're here is we're also going to add additional features to add a price column, because as you know with the store, sometimes the prices of items change and so forth. So we'd probably want to note in our database what the price of a particular item was when it was purchased. So maybe we would say this one was priced at $50 at the time of the purchase. This one was priced at $45. So even if we had, like, maybe there was order number 2 that had 1001, maybe they purchased 3 of them, but there was a sale that day, so the price was down to $40. Now we can incorporate that information into our table. So now basically we've got this order table that has information about the order, which is the customer information, the date and time of the order, its ID, and then we have another linking table that contains all the order information. One other thing that we're going to add to our orders table, just so you'll be aware, is we're also going to add a tax rate column. And the reason for that is we're going to put the tax rate that was used when a particular order was made, because the tax rate can change. The idea being that when you look up an order in a database in the future, you want to be able to figure out exactly what you charge for tax, how much each price was, and so forth. Now, we could just create a column called total and store the total of the order, but another part of thing with database design is typically you don't want to store anything that you can calculate, because it's, in a way, it's kind of redundant. If we have all the information about the prices of the items and the tax rate, we can calculate the total, and therefore we don't need to have that extra information in the column, because extra information in the database, because we can already generate it. So in that effort, we're going to include a tax rate column, as you'll see in our orders table. Now, one thing that we can actually do is further normalize our database by moving customer data into its own table. So, for example, we saw in our last version of the orders table, each order had the order ID, the tax rate, the date and time stamp, and then the name and address of each customer. And so, actually, if we flushed it all out, and showed all the different columns for a customer, and so on. We can see that we might have order 1, just write down a fake date, 10% tax rate, Joe Smith, who lives at 101, say Main Street, and doesn't have an apartment number, and we could put a city and state. Well, let's say typically, hopefully for our store, we want multiple customers to come back to the store. So we'd like to have Joe be able to make more than one order. So let's say Joe makes another order, order number 2. Joe Smith, he's got the same address as before. So now we can see that we've got redundant data in our tables again. And as we learned in our lesson on linking tables, part of normalizing a database is to reduce redundant data. Because right now we basically have all the information about Joe Smith's address, Joe Smith and this customer Joe Smith and his address listed in our table twice. So we've got taking up more space than we need to. We could separate it out and put it in one spot. Additionally, if Joe changes his address, and we need to know that for the future, and we wanted to update that on our orders, we'd have to go and update each individual row that Joe has. Instead, what we can do is, in a way, create a link to another table and extract that information out and put it into a customers table. So now we can have a unique ID. We'll generate a primary key for our customers table called cus ID. It'll have all of that same information, except it'll have this additional customer ID column. So now if Joe comes back to the store, we can update his address in one spot, and what we can do is we can erase all of the customer data from this table. And instead, we'll include a foreign key column that's going to be a foreign key to this customer ID. So we're going to say customer ID equals 1. Customer ID equals 1. So now when we look up information about an order, we look in the orders table. We see that order 1 was ordered on this particular date with this particular tax rate. We can see that the customer that ordered it was a customer associated with ID number 1. So then we could look up the information in the customers table, find out all of Joe's information, and we could do that for every order that has customer ID number 1. Additionally, as we saw on the last page, all of the information about the items in a particular order is stored in our linking table, where we have order number 1, item 1001, quantity, price, and so forth. So we basically have all this information spread into 3 different tables to, it seems it's more complicated, but it makes our database in ways more efficient. And the reason that we're bringing that up in this lesson is because now when we want to get information about an order, for example, we're going to be adding orders to our database. We want the administrators to, for the purpose of our database, our website administrator to be able to go in to the admin site and look up all the orders that have been placed. Well, in order to do that, we're pulling information from a number of different spots. So that's where the concept of a join comes in, which is where you can query data from multiple tables. So when we want to find information about order number 1, not only do we want the information in the orders table, but we also want information about the customer, Joe Smith. So we're actually going to be creating a query that in one result set is going to pull information from the orders table as well as the customers table. Because there's only one customer associated with each order, we can do that in a single result set. We can't do that with orders items, so we're not going to be performing a join, as we'll learn about, on the orders items table because there's multiple items associated with each order, and there's not really a good way to do that with joins. But for our customers, it's going to work out, and this is something that you'll be commonly using as your databases get more complex, where you'll be basically pulling data from multiple spots. So now I'm just going to walk through the creation of the tables that we're going to have to represent orders in our database. I've already logged into our MySQL monitor. So I'm going to create the table orders. We're going to do a typical unsigned int auto increment for our primary key. We're going to have a date time ordered column, which is going to be the date and time that an order was made. That's going to be our new data type that we learned about, date time. We're going to have the tax rate, a tax rate column. It's going to be the tax rate that was used at the time the order was placed. And for that, we're going to use a decimal that is going to be, or a floating point number that's going to be 3 digits long, all of which are after the decimal point, so we can have basically a 3-digit percent amount. So like 0.975 would be 9.75%. Excuse me, if we did 0.097, we could do 9.7% and so forth. And so that's going to allow us to hold our tax rate. And then we're going to create a cust ID column, which is going to be a foreign key that's going to link to our customer table. And because we're going to be using an unsigned int as the primary key for that table, we list that as a primary key. We list that as the same data type. So now we've created our table. Which is going to look like this with these 4 different columns. We're going to create the customers table to store the customer information, so that basically we can have multiple customers making multiple orders. And then we're just going to add all the different fields for our customer. And we're just using variable length strings for all of these different fields because they're going to be able to vary. Except for, in particular, our state and our zip code, we know that the state's going to be 2 characters long and our zip code will be 5 characters long. So we're going to use car data types for those. And now if we look at our customers table, we can see that it contains all the information. And this, when we look at, if we remember our web application, when a user submits information when completing an order, they put in their first name, their last name, and then their address, and this is going to embody all that information. And then finally, we just need to create that linking table that's going to link orders or items items to a particular order. And we're going to have a double column primary key, because an item can only be in an order one time. So that's a unique combination. And we're going to give them the same data types that the primary keys have in their respective tables. So we have order ID. Item ID is going to correspond to the ID of an item in our store. And then, as mentioned, we're going to have quantity, which will just be an integer. And then price, which is the price of the item at the time of the purchase. We'll have it be the same as the price column in our items table, which is a decimal with 7 digits long with 2 after the decimal point. So now we've got our 3 tables set up that are going to be able to hold information about our all of the information about our orders. And we can see here we have oh, and the one thing I forgot was, let me go ahead and actually get rid of, I forgot to assign a primary key. Just going to redo this statement. And now we can see that they're the primary key. So now we've got this set up to be able to add orders to our database. What we're going to learn about now is how to query information from these multiple tables. And basically what we're going to be doing as part of the required homework for this lesson is making the same setup on your own home database, so that you'll be able to use our new version of the web application. That's going to give you additional practice with using create table statements, and it's also going to give you a better idea of understanding of how the tables are actually structured to work together. So a join, as sort of implicitly mentioned, is a way to extract data from multiple tables in a single select query. So, for example, when we want to pull up an order, we want to pull information from a row in the orders table, and then we also want to pull information about the customer associated with that order. Now, we could do that in 2 separate queries. We could run a select query on the orders table and say, give me all information about order number 1. Then we could pull out of that data set, result set the ID of the customer that's associated with that order, run a select query on the customers table, and then pull that information. But joins allow us to do it all in one query, so we can have one result set that we can sort of parse over. The basic and the most common type of join is called an inner join, and it uses the inner join SQL keywords. And basically, this is what a join query looks like. It says select all the columns from the orders table that's joined with the customers table. Now, what this query basically means is, when you just say have a query that's just like this, where you specify the name of one table and you specify that it's an inner join, that it's joined with the other table, basically the result set is going to be a combination of all of the rows of the orders table combined with all of the rows from the customers table. So, for example, if the orders table had 5 rows in it and the customers table had 2 rows in it, our result set from this query here would be 10 rows, and basically it would be a combination of each of the 5 orders with each of the rows in our customers table. It's a little abstract, so let's take let's look at a quick example. If I create a quick table called employees, that's just going to have an ID for the person, a name, and then we're going to link them to a particular department. So we're going to use a foreign key from another table. We're going to link them using department ID. And let's go ahead and put someone in this table. Move it up a little bit. So we have Joe Smith that's going to be in department number 1, and then Jane Jones, which is going to be department number 2. And just to look at what our department table looks like, if you don't remember, we have 3 departments in our default setup: apparel, electronics, and sporting goods. So now let's say we want to, now we're going to show you what an inner join would look like if we join these 2 tables, departments and employees. So we do select, and we're going to select all of the columns from employees, and we're going to join that table with the departments table. And as you can see, we have 6 rows in our resulting table because we have 3 rows in our departments column and our departments table and 2 rows in our employees table. And basically what that inner join does is it just creates sort of a giant table that matches each row in the employee table with each row in the department table. So we can see that Joe Smith, actually let's do this. We can see that Joe Smith, he's 1 entry in our employees table, but he's matched up with each different department. So there's 3 rows here, 1 matching Joe Smith up with department 1, 1 matching Joe Smith with department 3, department 2, and so forth, and the same thing for Jane Jones. And so that's what basically an inner join is it creates a combination of all the rows in all the different tables. This particular case is not very useful, but what we're going to learn in the next slide is about something called a join condition that's going to allow us to define information like, basically we want to find out, typically what we want to find out would be information about Joe and the department he's in. And so what we can do is, out of this table of information, this join table, we can restrict the rows that show up. For example, we'd only want the row where the department ID in the employee table matches the department ID in the departments table, and that would give us, say that in our same query, so if we ran that query, we would be able to get the information about Joe Smith and the name of the department he's in. It doesn't really match up, that we don't really care that he's matched up with the row that matches him up with department 3 and number 2. We want it where they're the same. So we're going to learn about that in the next slide. So a join condition is pretty much like a where condition. It basically specifies which rows you want from a result set. So we learned that the inner join has that giant table result set. It combines all of the rows from all the different tables into a giant table. And what we can do is, after we have the same query as before, select star from orders, inner join customers. We can add what's known as a join condition that's specified by the keyword on. And what we're going to say for this particular join would be, give me, after you combine all of the rows of the orders table, all of the rows of the customers table, only give me the rows where the customer ID of the orders table matches the customer ID of the customers table. And basically that comes up because in our order table, this is the order ID, the tax rate, the date, and then we have a customer ID. So for example, cust ID 2. So if we did a join on both the orders and customers table, it would pull up a table that would, if there were 5 different customers, it would have information about each customer associated with this order. So it would say order 1, and it would match it up with customer 2 and customer 1 and so forth. Well, we're interested in where the customer IDs matched up. So we actually, this order clause, or this join condition, would actually get rid of this row from that join, and it would say, only give me the rows where the customer IDs of those two tables match up, because that's basically what we use to link the information from those two tables together. Because join queries involve multiple tables, you need to be able to specify specific columns from specific tables, and that's what we've done up here. And the syntax for that is you specify the table name followed by a period followed by the column name. And so that's what we use in our clause here, where we said the customer ID column of the orders table is equal to the customer ID column, of the customers table. And basically they work the same way that a where clause does. You can have and statements, you can have or statements, so you can add multiple conditions that further define which rows you'd like to receive. So for example, to perform a more practical and useful query using a join on this employees table and department table that we just set up, we're going to say select all of the columns from the employees table and the departments table, join them together, so basically have this giant table, and then we're going to specify a condition, and we're going to say only give us the rows where the department ID of the employees table, the department ID column of the employees table matches the department ID of the departments table. And when we run that, we're going to see that we get two rows. We only have two customers, we only have two employees. Each one's only assigned to one department. So as you can see, what it's done is it pulled the information from the two different tables. You can see that from the employee table, it pulled the employee ID, the name, the department ID that it's in, and then because it pulled all of the columns, because we specified a star here, it pulls all of the columns from the departments table as well. We have the department ID and the name from the departments table, and you can see that these two department IDs match up. Same thing for Jane Jones. So that's how we would pull information together, and that's how in our web application we're going to pull information from the orders table and then also pull information from the customers table. Now one thing you'll notice here is because we've used the star, that star implies give me all of the columns from the first table employees as well as all the columns from the second table. Because they have this matching column department ID, it actually shows up twice because they both have it, and we're not necessarily interested in that. We're just interested in the other information, for example, that might be related, or it might just be only want to see it once. So what we can do is we can change our select query, and instead of specifying all the columns, whereas before we know that we could specify, for example, name, and that would give us the name from the employees table. Well, because we're using multiple tables now, we're going to specify the table name followed by the column name that we want. So let's say we want the name of the employee from the employees table and the name of the department from the departments table. It doesn't look like it's fitting on one line. So basically what this is saying is give me the name column of the employees table, the name column from the department table, from the join of the employees and departments table, where employees.department ID equals departments.department ID. And so now we've basically got the name of Joe Smith. He's in the apparel department, Jane Jones in electronics. So that's another way that we can use this table name, column name syntax within our query. Not only can we use it in an on join condition, but we can also use it to specify what columns we want to get. And so basically that query made use of both an on condition as well as specifying what columns we want. Now one other thing that we could do is typically when we're doing this, we also want to only maybe pull up a particular user. We want to find out what department Joe Smith is in. So if we know Joe Smith is in has employee ID number 1, we can also add an AND clause to our join condition that says also only give me the rows where in the employees table the employee ID equals 1, and that's going to pull up Joe. And so as you can see, these queries are getting more complex, but allows you to pull a lot of information together. Oops. So that we learned sort of the explicit method of specifying a join between tables. There's also something known as an implicit join, which basically is just a simpler syntax for specifying that you want to inner join two tables and pull data from both of them. The way you do that is you simply say select, you list the columns you want, and then you say from all the tables you want. So when you say from, and then you list two tables separated by a comma, that's going to perform an inner join on those tables. So that would be the same thing as if we had written from orders inner join customers. So this right here is the same thing as this. It's a little less syntaxy with advanced words. It's a little more intuitive, and then instead of an on clause, we can specify a where clause, which is the same as our join condition, where we had on orders ID orders.custom ID equals customers.id. We now do that with ORs. So for example, this same query that we just ran, where we pull the employee's name, department's name, and we have employees join with departments, and we get that join of both of those two tables. Actually, set a join condition so that it limits the results. So we have our two different rows here. So we could write this query right here that's an explicit join. We've explicitly specified we want to join between departments and employees. Just another format, another syntax for doing that would be and by separating the table names we want to join by a comma, we're basically specifying that we want those join, and then we're just saying and then from that, join, give me all the rows where and we can see that we are able to get the same information. So basically, implicit joins are just a sometimes simpler and more it's a more intuitive syntax for doing joining two different tables for a query. So one other thing we're going to learn before the end of the lesson is related to using joins as something known as aliases. As you could see, our queries are starting to get longer and longer and more complex. One of the things that SQL allows you to do is it allows you to basically specify aliases, which is in a way kind of like a variable name or a shortcut, a shorter name to refer to a specific table. So for example, we could say if we wanted the order ID, the first name and the last name of our customer, from the orders table that's joined with the customers table, where the customer ID of the orders table equals the customer ID of the customers table, what we can do is when we list orders, we list a table, we can use an as clause afterwards and say as lowercase o. So basically what this is saying is select these columns from the orders table, which in this particular query has an alias that can be used for it as o. So we can, basically this is the same thing right here as orders.order ID. And what it does is it just makes our query, less typing that we have to do, makes our queries a little simpler, and we can do the same thing for the customers table. We're going to say we're going to refer to the customers table within this query as C. So this is going to say get the first name column from the customers table, last name column from the customers table, and this is going to say the join condition is going to be where the customer ID of the orders table equals the customer ID of the customers table. So again, looking back at our other query that, as you can see here, was rather long, we can go ahead and change it a little bit. We're going to call our employees table E. So we're going to give me the name from the employees table. We're going to call our department table D. Give me the name from the department table. Actually, let's do a regular inner join. So we're going to use E as the alias for our employees table. and we're going to be able to pull up the same data. Now you might say, well, that query is almost as long as the other one is, but let's say that we have 10 different fields that we're pulling from, 10 different columns we're pulling from a particular table. That's significantly going to shorten the length of the query. Also, we might have many more join conditions. For example, if we add one more join condition where the employee ID equals 1, so we're just looking up Joe. That's another spot where we can use it as well. And so it's just going to significantly shorten the queries in a way to make them a little bit easier to read and write. And so that's the purpose of aliases. So for the required homework, I'm going to have you create the 3 tables that we need. The 3 tables that we're going to need to use orders in our database, the ones that we learned about this lesson. I'm going to create a table called orders, just like we did here. It's going to have 4 columns: order ID, date, time ordered, tax rate, and customer ID, which is a foreign key that's going to point to a row in our customers table, so we can have multiple customers linked to multiple orders. You're going to create the customers table just as we had done. It's going to have a primary key column, which is cust ID, which is what we're going to use to link an order to a customer. It's going to have all of these different fields for containing information about a particular customer. And then finally, we're going to have our order items linking table, which is going to allow us to link multiple items to a single order. And so the primary key of the table is going to be a combination of order ID, column, and item ID, which in this particular table are foreign keys. The order ID is a foreign key because it refers to a primary key of the orders table. The item ID is a foreign key because it refers to a primary key of the items table, so that way we can uniquely link a unique item row to a unique order row. And then we're also going to specify the quantity, which is going to specify the quantity of this particular item in this particular order, and also the price of this particular item when this particular order was placed. And so when you go ahead and set that up and run these create table statements, you'll be able to have your database set up for the next web application version that we're going to be going through. So that ends today's lesson. Thank you for watching educator.com, and look forward to seeing you next time.